Welcome to tutorial video to get you started stepping forwards on task 3. For this task you have the first question, which is basically trying to teach you how to work with comparators that are then given to another piece of code that expects this. So this is on the outside of a class where it's already been written, but it expects a comparator to do its work because everything else in the class is generic. So you have some beginning starting code that is there then to help teach you a few new things and show you how you're supposed to add this in. So first off, what you're seeing here at the top, so this is in the student system class for question 1. The first thing you're seeing at the top is called an Enum. It's a way to create a constant where you are guaranteeing the type that's actually set to in the ranges of values. So when you declare it, you're now declaring a new data type. This one will be called sort by, and you are having the specific choices that can be set to for this variable. So throughout the rest of the program, you'll see now, since it's a new data type, it can be used as a return type, as a parameter, and as a local variable and comparisons. We have an array list, which is going to be holding student objects in here. The main point of this program is it basically does sorting of this list and then listing the students out. So it first sorts by name, then lists them out, sorts them by ID, and then sorts them by age. The load here is just some temporary hard-coded data just to get the program moving forwards. And then we have the sort class list, which takes in a parameter, one of our new enums, then to say, okay, what's the type we're working with? And it then sorts the data. And the way it does this is by using the collections class. Now when Java was built and you had all these libraries, you first had a whole bunch of collections classes that are meant to store data in different ways. And then you had utility classes like collections that provide methods like sort for you to do quick work against that list. So here what you do is I'm passing in an array list, I am giving it a comparator, and then when we come back, this array list that we passed in will be resorted, so organized based upon what comparator we use to do the comparison of two objects. So this is the steps if you're on the outside and you're calling a method that requires a comparator to do its work, is that we have to have a comparator that we make and then we pass it in. Now, little in the video later, you'll see where this compare by name is coming from, is how you make your own comparator to do a specific type of comparison. So here, we just have one that does it by age, and then one does by ID. Sorry, one does by name, one does by ID, and we have to add a new one that does it by age. The list all just goes through printing out all the student objects to the screen, and the main just starts everything up. The student class itself just has a name, an ID, and age, and a basic constructor, a method for formatting output strings of it, and right now some helpful methods to keep things encapsulated for comparing itself to another object. So you have here where we're taking in another object of type student, and so comparing the current object to the one that's passed in. And here you can see that even though name at the top has been declared as private, since we're inside the same class in Java, it allows you to bypass encapsulation so we can directly access the internal instance variables. So you have a method of writing here for compare name, compare ID, and one for compare age. And what all of these follow is the kind of rules can be used for later for comparator, that when the two are the same, so if the age in the current object is the same as age of other, it returns back 0. If the current age is less than the age in other, then it returns back a negative number. And if the current age is greater than the age that's in other, returns back 1. So this is just showing you how you can, when you're starting to design your objects, you don't need to just have getters and setters and do all the work on the outside of the object. You can actually start designing it so a lot of it's kept encapsulated internally inside the object, making it easier for changes in the future. Now if we go to compare by name, you can see that beginning step of, okay, well, if I need to have a comparator do comparisons, I need to then create it. And we need to use the comparator interface, so we have to have implements. Comparator is a generic interface right now, so you can have to declare it, and then we can specify the type that it's comparing. So we're making ones that compare students' objects, but in this case, it'll only compare their names. The other one here is then doing the same thing, so comparator for students, but here we're just doing work to compare the ID numbers. Now our first step is here, we need to actually make a new comparator to compare by age and then go modify the rest of the program, because we're going to have to come back and come up to our sort method here, and the way it's doing it so far is calling collections.sort and using different comparators to do the different sorting based upon name or ID. So we need to first create a new one by age. So here at the top we'll make a new class. Give it a nice name. Here in the middle where it says interfaces, we can do it the way of adding an interface. So I just clicked add, start typing the one I'm looking for, and make sure that it says comparator java.util. Okay, selected. Make sure it's there, and then go finish. Now we could have typed this out, but that was one way of showing another way in Eclipse that you can get it to actually add it for you. Next here is public class compare by age implements. It has the T here, but we have to specify now, okay, for this comparator, we're not making it generic again. We're making a specific comparator again to compare student objects. Okay, so that part's fine. The next one, working with an interface, you need to actually implement all the methods that are defined in it. So you generally go look this up in the API and copy the structure, but here we can go with the comparator. I can use an Eclipse to then just add the unimplemented methods, and then it creates the one that we expect in here is compare, giving the two objects. Now again, I have to remember that, okay, from this it has to return back if 0 is equal to, like if O1 is equal to O2 in the way we're trying to compare, returns back 0. If O1 is less than O2, negative number, and if O2 is less than O1, then it has to be a positive number. Now making this faster, there is already a method inside the student class I've written that does that for us and compares by age. So we can just call that here, can check to make sure, okay, yeah, O1 comparing to O2, boom. And we are done that for right now, because this does the work for us for that comparison. So if I go here, I'm just holding down the control button, moving my mouse over the method, and going to open declaration, just so you can see where that's coming from. So we've jumped to the student class, and you can see it's done the comparison in the right way that we expect. So that's the compare by age comparator. So that's you make it first. Now we've got to go use it. So I'm going to go back to student system, and I'm going to start adding in a new choice here for the sorting. So I'm just copying the case for ID and modifying it from here. Next, I select by age, and all of these three are coming again from our enum defined here, so name, ID, age. We want to then just change what comparator is being created. Make sure it's making our new one called compare by age, and then we are done. That's all we need to do to add a new sort from this, and why these comparators can be nice when you use them externally with some code that's already generic. So if we go and run this, you can see from the console that first list by age, name, so we can see them being alphabetical. List by ID, we can see it resorted, and now all of the new IDs in order. And then we have the list by age, and we can see the ages changing here. Okay, so that's question 1. And so that's meant just to show you how if you have code that's generic and it's expecting a comparator, and you want to make a new weighted comparisons, that's how you make and set up the object and then passing it in. So that's on the external of the object. Now if we go to question 2, this is supposed to teach you again of working with generics. So this is the opposite side. A class that's not generic, and we want to turn it into a generic class so that the data type can be specified later. And in this case, there's going to be cases where we're doing comparisons of data, where before it was comparing integers, which is fine to do, but when it's generic, we don't know what the data type is, so we'll need a comparator to do that work. So now we're going on the opposite side and stepping into that class. So this is question 2. And we have turned to generic, and it's saying that we must make data here that's an int, and this array list that's an integer. So instead of having these hard-coded here, we're now having that can be specified at the time that the node is created. So first thing, you want to make it generic. You go to the name and you go the greater than less than signs, and next we give it a parameter, so a data type parameter name. You can make this whatever name you want, upper and lowercase, does not matter. I just like to use the word type in all uppercase so it's easy to see. And next I start replacing everything. So I'm going to go through this replacing all the data first and get it syntactically correct so that it compiles, and then check everything for semantics when it comes to comparisons. So first, data must be generic, and then for this array list, it must also be generic. So that's set up. Now we need to go through, and everywhere else where there's any errors that are popping up, we need to also modify those to work proper with the generics. So here we had a constructor with so far an int for the data is hard-coded, and we're passing it into our data that we now made it generic. So we need to change that parameter right there. So now we're okay for that. Next we have the get data. This is returning an int, but we're trying to return something that's generic. So now we also need to change that. We have the public void add data point. We're trying to add to the array list, but it's expecting a generic type to be added. So we can't put this int here anymore. This must also be generic. Here. And now a little bit harder one is now we're doing the is same, and we're comparing to another node object, but we've made node now here as generic. So we also need to say here is that, okay, I'm only going to accept node objects that have also been set to the same type externally, and that's what I'll compare to. No more red lines yet till we get down to here, and this is where we're getting data out of both of the array lists, so the current object and next object, and right now it's being stored in integer, but now we don't know the type. It's supposed to be generic, so we put again that same type parameter that we passed in. Okay, so no errors here, no errors here yet. But what we have is syntactically got this correct, but we have to check for the rest of the code and see if there's any comparisons of data that's actually being done. So right here we have data from the current object and data from the other one, and we're doing comparisons to them. Okay, that's going to be a contentious point because syntactically this will compile, but it'll not do the comparisons as we expect. Now that it's generic, it's treating it like any other objects, and so it'll just be comparing your object reference, which will just be the actual memory address that's stored in those objects. So the only way that this will return back true is if the current object reference is also holding the same memory reference as the other .data. And we don't want that. We want to compare them as individual separate objects. They're actually just values internally. So we're going to need a comparator be passed in to do the work for us. So whoever is going to call this method will have to create a comparator just like in question 1 and compare it. We also have the case coming down here where we're taking the data out and we are comparing the two values. So step 1 is, if we're doing the is same, we need to force whoever's calling this method to give us a comparator. So we just need to make sure that we select the type to be comparator. And we have to make sure that it's a comparator for the type that the current object has been set to. And just give it some name. I like to call it CMP just for compare. So this means we need a comparator of whatever is the generic type that this node has been set to that can then now do the comparisons for us. So when we come here, I'm just going to comment out this line to do some of my work. I have to set it up so I'm comparing data and other data to see if they're the same. Well, for comparators, that if we call CMP, so if I go CMP dot, I've got my compare method right here. I want to compare data to other .data. And what happens is that it'll return back 0. So if this has been coded and whoever's made the comparator properly, is that it'll return back 0 if these two things are the same. So now I just compare to that. And I've got the same as what I had over here. Now I'm just going to put brackets around this. This has no point you have to do it. I just like to make this easier to read by saying that this method call with this comparison is all within one. So syntactically it does nothing. It's just more for aesthetic looking and reading of the code for myself personally. So we have that working. So all this is doing here is first is comparing, is the data between the two objects the same? Okay, that's fine. Next is comparing, is all the data and the array lists between the two objects the same? So first checking, is the size of the two array lists the same? If not, then stop because they're not the same. Otherwise, go through every element in the one array list. Now we know data points and the other data points are the same size, so we're fine to have a for loop that stops at the same point. Get the values out of each of them, and if at any point in time they don't match, then say that we haven't, actually the lists aren't the same, and then break out. So we need to change this right here because now they're not ints, they're actually our generic types. So we need to use our comparator again. So I will go cmp dot compare, and we have value 1, value 2, so Eclipse picked those out right for us. And what I want to do is where they're not the same, so if it doesn't equal 0, then we want to go in, and that's the equivalent of what we just had right there. Okay, so we've got that syntactically and semantically correct. That's in here, this node class. Now the difference is now you've also now got to go, because now we're not inside the class, we've got to go to the outside of the class and now modify all of this to make sure that it works properly. So now these are now generic, and these are supposed to be ones that are working with integers. So I need to add this into the type. So just like when you're working with array lists. Okay, so key thing here is saying integer. I'm just doing the brackets here. It's required for generics and shorthand. I could put integer here, and that would be purely legal, but now because we have it defined here and we're making this object, it knows that everything's okay. But I'll just add them in anyways. There we go. So those are fine. The adding data points will be fine. They work with integers because we declared it here. Now the problem become for the is same is we need that comparator. So there are none here. So just like question 1, we need to go and now make a new comparator to compare for integers. This time I'm going to manually add the interface. This must be for type integer since that's what we're comparing here. Get it to add our unimplemented method. And now we need to go through following the rules for the comparisons. So I'm going to assume that they're the same in the beginning and then just check every other condition. So if we have if O1 is less than O2, then result equals -1 to follow that rule. Else if, and this must be an else if to do the comparisons, is that if it's not less than, then we check, okay, if O1 is greater than O2, equals a positive number. And then finally from there, the only logical case you could have is they're equal. So if O1 is less than O2, then instead it's -1. Else if, so if it's not less than, if it's greater than O2, then set the results to 1. And then finally we could put an else, but here our default is that we set it to 0. If it gets through all these to, the only case it could be is that they're the same. So we've already set that before and just kind of saved one smaller line of code and one check and done the return. So we've now made a comparator that can be used for any point in time when we want to compare integers from here. So now we need to just go back to the main. Oops. Make our compare integer cmp equals new. So CMP okay, so everything's compiling. You can go and run the console and check that you've got everything working properly. So that's question 1 and question 2. So again, question 1 helps you with making a comparator and passing it into code that requires it. Question 2 is practice of working with generics, where then internally you may need to work with a comparator to compare with objects, and then going back to the main and making it. And now for question 3, both those tasks were actually needed because here now you have your doubly linked list that's been mentioned before in the first intro video for this task, where you must make it pass all the actual tests, and following that you've created a doubly linked list. And so this is where we're inside of a class, and now we need to actually work with the generics. So you have things like get size that we'll be covering in class, and everything from here. And what I'm going to do now compared to what was done on the tutorial on Friday is just add a little bit more, where I'm not going to do the code, but I'm just going to talk about the add to front and add to end and the situations that you expect. So for this, I'm going to switch to OneNote, right here, and we'll draw some of it out. Now if we're in the add to front method or the add to end, you have the first case as if the lists are empty. So if you have, in that case, like we've done with single linked lists, we would have start set to null, but in this case we'd also have end set to null. And that what we knew is we'd have the new node created here. You'd have your next, and you'd have your previous pointers in there, and boom. So it's the double linked list. So this is how it would look before, and so we know here. This is the previous right here. So you set that, and this is for the add to front, add to end, just like we were doing the single linked list. So if it is this. Now, if we had the different case that, okay, it's not an empty list, we at least have one from right here. This is the case, and we come to the add to front. so they add to start. What you know is you could have something like we've seen here where there's one node or whatever else, but we're trying to add in a new node so that it goes being in front of the current one that's right here, and that becomes our new start. So this is very similar to the linked list, but now we're worrying about, okay, where do our next and previous references go? So you have next, you have your previous reference right here, so referencing. So when you start this, you have to remember you want to be careful about not moving your start reference from right here, and we want to link everything up. We know that we have the previous reference up right here, and we have the next reference. So, well, okay, this has got to be, the new node is got to be the actual starting point. So this is going to be the new start, this thing right here. So that will be the new start. So first we could go through a couple different steps. What we know is, okay, well, I've got start, I have this node, and there's supposed to be one before the current start node. So its previous reference has got to go back to the new node. So we don't have that to null, we have the previous right here. I'm just going to call that kind of step one. So from a start node dot set previous, you want to go to new node from right here. Now new node right now, its next reference, it should be going up to this one. So we have new node right here, next reference equals the start. So this goes up here. That's step two. So new node dot set next, passing in start. We check, okay, do we have previous in our new node? This was from the list, null. Yeah, okay, yes, we're okay there. Everything else after that, no, we don't have to worry about, but our start reference now needs to move down and reference what the actual new node is. So this has to go here and going down, and that will be step three. So step one, your old start node dot set previous to your new node. Step two, your new node dot set next to your old start node. And then step three, your start node, the object reference itself, must reference back to here. Okay, well, that's the start. Now let's go to the other one. What if this is add to the end? So let's assume that we have here, so our new node, so our start reference right here. So we have this case here, we have new node, reference, its next reference, and the previous. This is holding the reference to it. Now we're trying to go to adding this new at the end. So we can say this is the end reference, and it's supposed to come after the current one that's right here. That's marked by the end reference. Now in class we had a single linked list that had to go from the beginning and move a reference to the very end, but in this case we have an end reference, so we're okay. So the idea here is we have to start linking everything up, that they're matching the same way that this node that we have right here, its next reference must be null, but its previous reference has got to go up to the node that's up here. So step one is to set the previous reference for your new node must link up to this node. So that's step one. So that would be new node dot set previous, passing in your end. Next we've got to make the old end, that's next reference, go over to here. That's step two. So that would be your end dot set next. Right here, passing in new node. So we've linked everything up right here. That's still following the new node, still follow the line. The previous still keep coming back from right here. But now we need to then modify, well, the old end is still pointing to the old node. We need to move it forwards. So step three is make your end reference equal to new node. And there you go. We've got index 0, 1, 2, 3 with the end references properly set up here. So janky, a little bit of a drawing, but you can see the kind of steps, and that's your add to front and your add to end, maybe modifying stuff from your start code. So after this, you need to do things like add sorted. Well, very first thing in there, if the list is empty, you don't have to do anything for actually sorting. You are just going, okay, if it's empty, then just like you did to add to front, add to end, you're setting those to be the first nodes. After that, you're using the comparator to find the right location of where to do it based upon these specifications above. So you need to go make a moving reference that steps through the list and finds the proper location to do the insert. And then after there, checks the proper update to know, am I then going to be inserting at the start, at the end, or am I inserting from the middle? This is very special cases from here. Your get method, just based upon the index, has got to move to the current location and return back the data at that spot. So it's a basic loop and moving reference. Your remove at, right here, and all these, if you're out of bounds, throws an exception. Your remove at must go to that spot and do a remove, so it's going to have to deal with if the list is empty. It's going to have to deal with if you're moving from the start or end, or if you're moving from the middle. Your contains is very similar to the actual get, but using comparator, that it runs the whole thing, just checking to see does it match anything. So this is basically a moving reference that makes sure to go through every single node, checking with the comparator, seeing if it returns back 0, and if it does, then you just return true, otherwise you return false at the end. And then you've got this handy dandy print method down here. Well, I hope all of you are enjoying your reading break and getting through this video, or after reading break and getting caught up on the assignment, and hopefully not getting into this tutorial video too late. But just continue to remember, if you've made it this far, you're still doing great, and keep going forwards.